Welcome back. Let's do question 5.41. Given the identity cos x plus y times cos x minus y is equal to 1 minus sin squared x minus sin squared y, we have to prove the identity. So remember that when proving the identity, you can work on both sides. You can work on the left-hand side and also work on the right-hand side. I want us to remember the compound angle formula. So remember that cos A plus B is equal to cos A cos B minus sin A sin B. And then cos A minus B is equal to cos A cos B, or cos B here, not cos A, plus sin A sin B. So now let's write our left hand side and right hand side. We have our left hand side and right hand side. Okay, we want to prove that the two sides are equal. So we have cos x plus y times cos x minus y is equal to 1 minus sin squared x minus sin squared y. Right, using our compound angle formula, we can see that this is cos x times cos y minus sin x times sin y. This is the first one, this one. Then the second one is cos x times cos y plus sin x times sin y. Okay, this is the second one. So now, if you check these two, it's actually difference of two squares. The right hand side is still 1 minus sin squared x minus sin squared y. But if you check this one, it's difference of two squares. Okay, so let's multiply these two brackets, which will give us cos squared x times cos squared y minus sin squared x sin squared y. Again, I want us to remember something. Remember from our grade 11 identity, cos squared x plus sin squared x is equal to 1. And then from this, we can get that. We can get that cos squared x is equal to 1 minus sin squared x. And then sin squared x is equal to 1 minus cos squared x. Right now, where there is cos squared x, we have to replace it with this. You see that the right hand side there is no cos squared x. So we have to eliminate cos squared x by substituting it with 1 minus sin squared x. So it's going to be 1 minus sin squared x times 1 minus sin squared y. Then minus sin squared x sin squared y. Now we have to multiply these two brackets to get rid of the brackets or to remove the brackets. So say we use the FOIL method, right? 1 times 1 is 1. And then we have 1 times negative sin squared y. We get negative sin squared y. And then we've distributed 1. Distribute negative sin squared x. Negative sin squared x times 1. We get negative sin squared x. And then negative sin squared x times negative sin squared y, we get positive sin squared x times sin squared y. Then minus sin squared x times sin squared y. Right, on the right hand side, we still have this 1 minus sin squared x minus sin squared y. Sin squared x times sin squared y minus sin squared x times sin squared y is 0. Okay, they subtract each other out. Then what do we remain with? We remain with 1 minus sine squared y minus sine squared x, which is equal to 1 minus sine squared x minus sine squared y. Right, addition is commutative, if you know. This is just the same. You can even rearrange this and say this is 1 minus sine squared x minus sine squared y, so that they look the same. Okay, they're just the same. Otherwise, up to this level is still okay. And then sine squared x minus sine squared y. We have proved that the left hand side is equal to the right hand side. Therefore, the left hand side is equal to the right hand side. We've proved that.